Hi, I'm John, and I'm a gamer.
Hi, John.
Gaming has come a long way over the last several decades. The debate on whether the media gaming has come a long way over the last game as art. Today's topic: glitches.
Okay. Alrighty. Yeah, just let me know when we should start.
Oh, well, we can start now.
Okay, awesome. Hey folks, Adrien here. So one of the things that we like to talk about a lot in games is how the games can break. Glitches come up a lot, and we've mentioned a lot of them in terms of speedrunning and how speedrunners use them. So I wanted to do kind of a side episode where I talk about some of the common glitches, well-known glitches, why they happen, and a little bit about how video games work so that we can, just so folks can understand that stuff a little bit better.
Yeah, definitely. And this is John here, by the way. But one of my favorite things about games in general is just the fact that it is a world that is constructed in a way that can break, like at all. It's just like, imagine if real life had glitches or some kind of source code, which I guess we don't know that it doesn't, that it has just been patched over the millennia.
Yeah. Yeah. You, in a video game world, it's not super uncommon for something to just like pass through a wall, while in real life, obviously, that can't really happen.
Unless you believe quantum physics. In which case anything can happen, but it's very unlikely.
Yes. Somehow all of your atoms have jumped through the wall.
Right? Because, oh man, I remember watching, this is a little bit of a diatribe, but I remember watching this documentary when I was like just entering the college, and it was like kind of blowing my mind about how, like, if you put your hands together, like your hands aren't actually touching each other. And in fact, none of the atoms of your hands are actually touching each other.
Right.
Like if every electron were in just the right place at just the right time, like it could be feasible that my hands would just pass right through each other.
Right.
Of course, it has never been recorded to have happened in history, but
nope. Yeah. And I mean, we could go into a whole spiel about how quantum mechanics work and why that technically won't ever happen, but I think that would get us a little too off topic. So yes.
We're talking about real stuff today.
Yeah, real things like Missingno.
Yes, I think that might be a good place to start.
Yeah, totally. The Missingno glitch, for those of whom aren't familiar with it, is a glitch that you can perform in the original versions of Pokemon. So Pokemon Red, Pokemon Blue, you can, if you talk to the bug catcher, or not the bug catcher, but the guy who teaches you how to catch Pokemon, which is in, I think, what is it, Viridian City?
Yeah.
And then fly to Cinnabar Island and then surf on that little strip of land that's like a little cliff. You can actually surf on it. And you get a Pokemon encounter. You will get this one of two Pokemon, either Missingno or Mysterious M. Their graphic is just completely all messed up. Their name is weird and has all these bizarre characters in it. And things just get really weird from there. For example, I think it's like in your item slot 6, it will like give you a whole bunch of that item. So it's an item duplication glitch. You can actually catch these things. They have like really weird moves. I think they have like 2 instances of like water gun and like sky attack or something. It's just really, really bizarre.
Also, I think Missingno is a bird type, which is not even a type in the game, right?
Right. Yeah, there's just all sorts of weirdness with it.
I hadn't even heard of Mysterious M.
Mm-hmm. It's fundamentally the same. I think exactly what happens depends on your character's name, which is weird as hell. But let's talk about how that actually happens.
All right.
So, first of all, we have to go over a little bit of background. So, in a computer, any computer, and in a Game Boy as well, there's something called RAM. This is the system memory. It's basically like a scratch pad for the computer program that's running the game. And the way that I like to think about it is it's basically like a book, where every page is a spot that you can put something on. And the way that the computer actually does, that it actually runs the program, is that it's basically a person who looks at every page. And some pages will have instructions on them. They'll be very simple things like write something down on another page, or add two numbers together, things like that. Or it can be data, again, in the form of numbers. So for something like Pokemon's name, its name will actually be on a couple of successive pages, and each one will have a single character in it, represented by a number. A equals 1, etc. It's actually a little bit different than that, but it doesn't matter too much. And as well, for things like the Pokemon's stats, those are all represented as numbers. It's basically, if everything is working properly, you start reading, and then okay, the first page through the 12th page will have the Pokemon's name, and then after that is going to come something else, and then something else. So everything is very structured like that. Mm-hmm. However, if the reader gets confused, if the reader starts reading on the wrong page, they don't know that it's wrong. So you could just open up the book and start trying to read random garbage. You can start reading something that has nothing to do with a Pokemon and its stats, but you can interpret it as one. So that's kind of how you get that weird stuff with Missingno, why its name is strange and all that. What you're basically seeing is in programming, we call this an aliasing error. Basically, you're trying to read the wrong thing, and the output is garbage. Similarly, the what do you call it? That like weird Pokemon image is basically just the result of reading random stuff in memory. Or there are some distinctions. When you're reading data, it's actually in the ROM, it's in the cartridge, but they're basically the same thing here. Basically, you've got a bad pointer, you go read somewhere random, and I don't know exactly what part of the ROM is being read for the Pokemon's, for Missingno sprite, but it is very clearly it's not meant to be a sprite, but it's being interpreted as one. Right, so it's like, the way that it's kind of coming across to me is like translating a cipher. Mm-hmm. Yeah, starting in the wrong place. So it's like so instead of say like the first letter should be like the first number should be the first letter of the Pokemon, and it'd be like Wartortle, be like whatever letters those are, or slash numbers. Instead, you're looking at entirely different numbers that have nothing to do with a character. Is that what you're saying? Exactly. And then you're just reading them that way. Yep. So you're like plugging the wrong variable, or plugging the wrong numbers into the equation. Yeah, very much so. Now, the fun part is, how does this actually happen? So whenever you have an aliasing error, that's the result. But in order for it to happen, there has to be a problem kind of upstream that caused the program to be looking in the wrong place in the first place. And the one from Missingno is actually really interesting. So the original Game Boy was not a very powerful computer. It was very, very limited in its capabilities, and it had very, very limited system RAM, which meant that only a very few pages to write stuff down on. And you might wonder, what does the Pokemon catcher have to do with any of this? Well, when the game plays that little cinematic where the Pokemon catcher teaches you how to catch Pokemon, it has to display his name where the character's name would normally be. Now, this is actually an issue because they have to save the character's name somewhere else so that they can restore it. And them being, clever programmers, they're like, okay, we need some memory that isn't being used right then that we can use to shove the name into. And what they did is that they used the region that has Pokemon encounter data. So this would be like what we call an array. It would be basically a list of Pokemon IDs that you could encounter. And it would probably also have some stuff to do with the percentage chance of encountering it. So it shoves your name's data in there. Then when the cinematic is done, it puts your name back where it should be in the area of memory dedicated to displaying the name. However, it doesn't go back and clean up what was in the encounter data. And the reason that flying to Cinnabar Island works is that cities have no encounter data. And you can actually get an encounter in the city of Cinnabar on that little strip. If you go too far, if you go farther than that, it will load legitimate encounter data and you won't find Missingno. But while the encounter data is in that broken state, then you can get encounters. But because it's based on what your name is, it's not a real encounter. So when it tries to go look it up, look up the name of the Pokemon, it goes off into somewhere weird, and that's how you get Missingno.
Or Mysterious M, depending on what your name is. That makes sense.
Right.
Okay.
I believe there are like some names actually. I don't think it will repro. I don't think the bug will actually happen for some names, but I think several very common names that people use, like Ash, will cause the bug. And I know that you can like put certain things, like you can name yourself very specific things in order to get like specific encounters, but I don't know too much about that.
Oh, that's interesting.
But yeah, that's how it works. It's basically all caused by the game. Yeah, it's all caused by the game misinterpreting its memory.
Well, is that like a common way that glitches happen? Like the game is just reading information from the wrong spot?
So that's a pretty common in older games. Newer games have things like actual operating systems in place to prevent this sort of thing, but it can still happen. But like I said, it's becoming less and less common. There's a lot more safety like guardrails in the programming to prevent it. But fundamentally, you can still get similar issues. Although a lot of games these days, it's happening. Like if you try to access an asset or what have you, like an item that doesn't exist, it's probably just going to fail quietly and not crash the game or give you something really broken. So it's really more of a product of its time, and they aren't super common. This kind of glitch isn't super common anymore.
Can you think of any ways that now, if they were to go back and patch that original version of the game,
mm-hmm.
they could fix it?
Oh, totally.
What's one solution?
Probably you can probably just with one instruction just prevent the as long as you clean up the encounter data after you talk to bug catcher guy, you'd be fine. Okay. Similarly, if you were to just make it so that you couldn't get encounters on that little strip, or if you made it so that you loaded the route that you're moving into, if you loaded its encounter data on that tile, any of those things would fix the glitch.
Gotcha. So from my understanding, there is no missing gnome. The game creates missing gnome under like specific circumstances. Which
correct.
And the fixes that you're proposing, the easiest way to do it would just be to prevent those circumstances.
Right. Exactly.
Maybe the only.
Yeah, exactly. In a modern version of the game, you simply wouldn't have this aliasing problem. You would there would probably be some extra data in there or there'd be some validation where the game would be like, hey, am I looking at the right thing here? Is this really a Pokemon data is this really Pokemon data? And it would probably bail out at that point and say, nope, that's not a Pokemon. We're not going to load that.
When you think about it, it's almost like just desserts, because like
Mm-hmm.
the existence of that character and the placement that they have him
Mm-hmm.
is already kind of ridiculous. Like, I don't know anybody who didn't already have 2 or 3 Pokemon by the time they came across that guy.
Right.
And he's there to arbitrarily explain to you how the world works, and he's also like the best avenue you have to break that world.
Yeah, it is a little ironic. One thing I will say is you tend to find glitches like this in situations where the devs are trying to make the game do something that it wasn't really made for. So, in this case, there only is one cinematic where somebody else is in the player's position. And probably one of the reasons that they didn't catch this is it happens early in the game. It seems to work fine. It only becomes a problem in this like super edge case. So that is oftentimes where you find glitches, is in edge case situations where the game is kind of in things that don't happen very often.
To draw another little parallel to the real world,
Mm-hmm.
I sometimes think like, I wonder who the first person was to realize that you could eat a nut more easily if you boiled it, or that you could eat that fruit at all.
Mm-hmm.
And like, how did they figure it out? Like trial and error. And what's even more baffling to me is, how did people figure this glitch out? It really does take like a lot of creative thinking to even like experiment with, unless they had some access to the source code.
Right. And I mean, given how we found it out, us kids found out about it passed by word of mouth. And back then, things like glitch hunting weren't very common. So I have no idea how somebody could have done it, but people do all sorts of weird stuff in video games, and it's just a matter of time.
Right, especially if you have like 1 million copies sold worldwide, like a game that popular that people are playing to death. Like,
yeah,
you got to imagine any little thing that could happen is going to happen eventually. Like,
yeah, exactly.
As infinite as that game sounds, like, yeah, I guess it was just only a matter of time before somebody, for no apparent reason at all, went and talked to the bug catcher guy, got a second tutorial, and then flew to Cinnabar Island and very carefully went to catch a Pokemon there for some reason.
Yeah. Yeah.
And it's nuts. And yeah, I think that like that is leads into like that word of mouth. Like, we talked a little bit about this glitch in our first episode, which kind of makes it a fun one to start with today. But it just like, and we also talked in that episode about word of mouth and how big a part of gaming that was back then.
Oh, totally.
And now we have glitch hunting.
Yep.
Which is just this whole other like subgenre of playing a video game, is figuring out how I can break the video game. Like,
yeah. So, some other stuff to talk about. So there's I talked a little bit about like memory aliasing bugs and how that caused Missingno in Pokemon. There's actually another kind of or is another kind of aliasing problem that can occur. And in this case, I want to talk about Ocarina of Time. One very well-known glitch there is the so-called wrong warp, where by doing, again, an incredibly specific set of things, you can basically, entering a blue warp, you can pretty much warp anywhere. Not quite anywhere, but you can warp to many, many locations, pretty much any scene in the game. So until some even weirder glitches were found, the world record for the any percent speedrun of Ocarina of Time would beat the Great Deku Tree, perform this glitch, and then warp to right after beating Ganondorf. And then they would proceed to, with literally nothing else, just run out of the tower, kill Ganon, and beat the game.
What would they do? Adult Link?
It would be a little glitchy. But yes, you would be Adult Link, because it's expected that you are Adult Link there. But yeah, the game is definitely not happy.
Glitchy how? Like, I'm imagining a fully grown Link, but with like stubby little young Link legs.
I don't remember specifically what happens in this case, but I know that there are some cutscenes that are messed up in other parts of the game if you go there as child Link when it expects you to be adult Link. You'll see a lot of like Link, normally like young, it's just young Link, but he'll like sometimes be stretching or like jumping around up and down just because the cutscenes were built assuming that it would be adult Link.
Nice. So then how does this one work then? Like
so this one is pretty freaking complicated, but it still comes down to the same basic thing, which is that you've got some memory, you've got a value in memory, and it's getting something weird is happening to it. In this case, though, it's nothing intentionally messing with the memory. It's not like in Pokemon where you get this problem because the developers explicitly and intentionally put essentially garbage data somewhere. They intentionally put the player's name somewhere that it wasn't really supposed to go.
Mm-hmm.
In this case, though, the critical value is let me see here. The critical value is called the entrance index. Or no, it's this. It's the scene index. There we go. I've got the documentation open here, so I make sure that I don't make any mistakes. So there is the scene index, and it's basically telling the game where the player is going. And in this case, what you're doing is the glitch is actually doing something where it is illegitimately writing data somewhere, where through a bug in how the game's bottles work, you can, or not the, is it the bottles? No, it's not the bottles, but using a bug with the game's item system, you can cause the game to actually write a garbage value to the scene index. And then when you change scenes, you can end up somewhere else. So again, we're having a situation where basically by changing some value, we're causing the game to load the wrong thing. For Pokemon, it was going off into some random garbage memory and creating Missingno. In this case, speedrunners very specifically manipulate that scene index to take them where they want to go. In this case, to right after beating Ganon, or right after beating Ganondorf. Now, the way that actually happens is a little bit complicated and a little out of my wheelhouse, but let's see here. Let me just read this again real quick.
So like my thinking right now, how it sounds to me is like in Avengers Endgame.
Mm-hmm.
Have you seen it?
I actually haven't.
Oh, well, never mind then. But it's like you have this like magic portal that you could go into, and it seems like it could spit you out anywhere. Mm-hmm. But then people figure out like how to use that portal to get exactly where they want to go.
Mm-hmm.
Which is again like the amount of time and thought that had to go into that, or at least some understanding of it. Like, how did you know that you had to have this item selected and jump in this many split seconds?
Yes.
Whatever it is that they had to do to get exactly where they want to go, because apparently this thing can take you to almost any cutscene, right?
Yep. Yeah, exactly. Yeah, let me just double check exactly. Okay, no, I was right. It is with bottles. Yeah, so there is a glitch in the game where you can play the ocarina without actual, like, basically you can play any item as an ocarina. It's a weird glitch where if you have a bottle with bugs in it, you release the bugs, you catch the bugs, and then while it's still in Link's hand, if you do a backflip and then press any item button, you will start playing that item as an ocarina. So you can like play your bottle, you can play your sword. It's a really strange glitch, but when you do that, the game doesn't expect you to do that. And something to do with how, like, basically when you catch something in a bottle, that value, basically it has to change out the item. There's another really famous Ocarina of Time glitch that Hallie and I did back as a kid, which is you start swinging to like catch a fish with your bottle and then change out the item that's on that slot. So like I did it with like Zelda's letter because you don't need that anymore. And the game still thinks that it's swinging a bottle, so you'll end up with like a fish in a bottle over that item slot.
Oh, so you can end up with an extra bottle that way?
Yeah, you can actually duplicate as many bottles as you want.
You can do an all bottle run.
Yeah. Yeah, you can't beat the game like that though. If you turn like the Megaton hammer into a bottle, there are switches that you need the Megaton hammer for.
Right.
Then you'd have to wrong warp to the end in order to beat the game.
But you can't.
Yeah, and perhaps the bottle glitch is simpler and easier for me to explain what I'm going for without getting off into the weeds with exactly how the wrong warp works. So what's happening here is that the game's code, basically once you start swinging, it's in the Link is swinging a bottle state, and it doesn't check to see if you've changed the item out after you've actually caught the thing. So basically, once you've caught the fish, it just goes, oh, okay, I'm just going to, I know what item slot this is. It's the letter, but I'm just going to overwrite the item with fish and bottle, because bottle and fish and bottle are actually two separate items.
Right. So the fish and bottle is designed to go on top of.
Yes, exactly. It actually overwrites it.
Overwrites it.
Rather than like the bottle having special knowledge. Like in the modern day, the way that we do this is the bottle would know what's in it, but it would still be a bottle. Back then, because of the memory limitations and everything, they just did it where they're two separate items, they just overwrite. And because of that, the code that is in the bottle swinging is pretty powerful. It can just write values to items. And when you do this in conjunction with some of the other weird stuff that happens during a wrong warp, you start writing very interesting data to the scene counter or scene index, and which then gets used to take Link somewhere else. But yeah, so there's that glitch. Another Ocarina of Time glitch that I think would be good to talk about is you can actually just straight up jump through the door of time.
Wait, really?
Yeah.
Like the first time you visit there, you can just jump through it and draw the Master Sword, and you're into the second act.
Yes, so that's another really common one in speedruns where people will immediately get out of Kakariko. There's a bunch of different ways of doing that. You can like backflip past Mido and just leave. There's also a way that you can go out through Zora River by exploiting the fact that if you fall into the water while you're talking to Navi, you'll actually just sink straight down, and then you can get out that way. But either way, you can just go straight to the Temple of Time and then just jump through the door. And this brings up a interesting problem that games have, which is you can call it clipping, you can call it like out of bounds. That's the term that they typically use in speedruns. And this is also pretty common among a lot of different games. And it's interesting to talk about why exactly this happens. So in a video game, collision, the ability of things to act like they're solid, has to be explicitly done. In fact, it's pretty tricky, even in 2D, to get it right. And a lot of games that basically have collision bugs associated with that. What happens in a lot of games, like in Ocarina of Time, is that the game's collision engine breaks down under some circumstances, normally when the player is moving very quickly, or any object. So one really common problem that like novice game devs have is they're like, oh yeah, I'm going to have a thing that like shoots a bullet or a projectile, and I want the projectile to move super fast. And then they get surprised when the projectile starts going through walls. And basically what causes this is the game's physics simulation runs in steps. So when you think about, a lot of people will talk about like the frames per second that they get in a game, normally in the context of people complaining that the game is running slowly, or people bragging about their computer setups where it's like, oh, I can run Crisis at 120 frames per second. What those frames actually are is they're simulation steps. So what the game is doing is, with its physics at least, each frame it's calculating a very small change in the physics of objects in the world. So if you've got a bullet flying, every step it's adding the bullet's velocity to its position in order to cause it to move. That all the objects don't actually undergo smooth movement. And if you just check, is bullet colliding with wall, the wall is only so big and the bullet is only so big. Mm-hmm. And once you get to a point where the bullet is moving so quickly, one frame of its simulation, it could be on one side of the wall, and then the next one, it's already on the other side of the wall with no collision detected. And that can cause it to just go through things. In the case of actually going straight through the Temple of Time door, though, it's a little bit more complicated. Link can't quite move that fast. Although there are other games where you can do that. For example, in Mario 64, if you reverse long jump, you can build up an enormous amount of speed and eventually just start passing straight through walls. With the Door of Time, though, what's happening is it's exploiting something else. So I discussed collision detection. In the context of a bullet, though, normally you just destroy the bullet if it hits a wall. And that's the resolution to the collision. For like Link, though, if he has ended up slightly in a wall, you need to push him out of the wall. And that's collision resolution. The way that all of this works is basically, if Link runs into a wall, what he does is he actually goes slightly into the wall and then gets pushed back out. And if you do this well enough, you can get, and especially if there's geometry that is conducive to this, like a certain acute angles. If you move fast enough, normally with like a what do you call it? A leap slash. You can get moving pretty quickly, and if you get enough of Link's collision embedded in the wall, the game won't know what to do, and it can actually pop you straight through the wall. It goes, because the game doesn't actually know which side of the, oftentimes it doesn't know which side of the wall is which. All it knows is that it's not supposed to let you through the geometry. And if you end up with enough of your collision on the other side of the wall, it'll be like, oh, you're supposed to be over here. And it just pops it straight through. So that's, sorry?
I was like, yeah, that looks right.
Yeah.
The game just sees a dot and a line.
Mm-hmm.
And it knows they're not supposed to be on top of each other.
Yep, exactly. And because of that, you can get, many games have problems like this. Some are a lot worse than others. Like Donkey Kong 64 has a glitch where if you're swimming, go up to a wall, enter first-person mode, exit first-person mode, you can just swim through the wall. For no reason. I don't know the specifics of exactly why that lets you swim through walls, but it's something similar where, just honestly, collision resolution is really hard. The programming component that handles especially the player's movement is generally called a player controller or a character controller. These are some of the most complicated pieces of software that I've seen. They have to deal with a lot of things all happening. They have to deal with the player's input. They have to deal with the animation of the character. They have to deal with a whole bunch of different states. Are they swimming? Are they jumping? Are they on the ground? It can get very, very hairy very quickly. And because of that, it's very common to have bugs in the character controller. Even modern games will have bugs like this. Although I hesitate to say that modern games are better about out of bounds, because they're actually not. There are still tons and tons of bugs, even in modern games, where you can end up going through walls, going through floors. Dark Souls, for example, has some very famous out of bounds bugs where you can just go straight through walls. So it's still something that happens in games to this day.
Mm-hmm. It's just sort of like a part of building a digital world.
Mm-hmm.
Yeah,
the biggest problem here is that computers generally don't have much of an idea of volume. If you look at a video game world, like a 3D world, everything is made up of faces, basically triangles that have no depth. You slap textures on them, you build models out of them, but there's really no idea. The computer has no idea of there being something inside of it. If you have a crate or a box, it's a cube, but the game, there's no concept for what's in there. If you clip in there, you're just going to see the inside of a cube.
Which is taking space.
Right, pretty much.
Mm-hmm.
And because of that, when you have terrain, the game still has no idea that the terrain is solid. So if this happens and you end up on the wrong side of it, you're just kind of out in space. A lot of games have different behavior for when you are outside of the geometry, and some of it can be very, very complicated. For example, like Metroid Prime and Metroid Prime 2 have their speedruns feature a lot of out of bounds. And the out of bounds movement is brutally difficult. You'll see them just doing all of this weird stuff. They'll be morphing and unmorphing and bombing at weird times and places. And it's all in order to satisfy these weird rules of the out of bounds state. One thing that I really like in Metroid Prime 2, which is funny, is that when you are out of bounds like this, the game's load triggers don't work normally. So normally in Metroid Prime, a room loads when you shoot the door. And actually, there's oftentimes triggers before you get there so that you don't have to spend all day waiting for the door to open. But what's interesting is when you're out of bounds, you have to explicitly go out of your way to hit those load triggers. Otherwise, the next room won't be there. And you'll just fall off into space.
So right now I'm thinking, especially because you mentioned Dark Souls 2, and after hearing that about Metroid Prime 2, how things don't load right if you're not in space. There's this one glitch. I never accomplished it, but when I was playing through Dark Souls for our Dark Souls episode, I remember seeing a speedrunner basically clip through the giant gate that only opens when you ring both bells by not letting the bridge render.
Yes. So that's another really common type of glitch, which is that oftentimes different parts of the game load at different times. This is another common glitch in Ocarina of Time as well, where the game has terrain and the game has actors, which is normally the term. These are things that move, they have logic. Oftentimes the terrain loads before the actors do. So if you can get the game in a broken state where the actors aren't loaded, you can, for example, just that door just won't be there because it's not loaded, and you can just walk straight through.
Anything that could potentially open.
Right, exactly. But also things like the monsters won't be there. In Ocarina of Time, a lot of doors won't be there, so that you can I think there's somewhere it's bombable floors won't load, or the water won't load. And all of these will, can be exploited in order to get around parts of the game.
Oh, that's so neat.
Yeah, cool. So I kind of said my shtick, but you asked me to give some context on a few other glitches. So let's talk about those a little bit. So the first one that we were talking about is the kill screen. So that is specifically in Pac-Man, where when you get to the 256th level, only half the level is there. The rest of it is just kind of garbage data. It's just a whole bunch of random characters and values and things that cover half of the screen, and you can't go any farther because the game hasn't fully loaded the level. So I did a little bit of research into this because I had heard about it before, but I didn't know too much about it. So basically, the reason that this happens is that it's kind of similar to the Missingno Glitch, where once you hit a case that the game developer didn't expect, weird stuff can happen. And in this case, what actually breaks the level is apparently the cherry counter in Pac-Man wasn't built to understand what happens when you get to the 256th level. Now, the reason that 256 is important here is that I don't want to get too deep into this, but basically they're at certain sizes. So if you have an 8-bit number, so that's 8 zeros and ones, you can go from 0 to 255. But once you hit 256, the number actually rolls back over and becomes 0. And this can cause some very strange things to happen. In this case, the cherry counter wasn't properly programmed to deal with this, and it causes the game to load a whole bunch of garbage, kind of like a Missingno, on half of the level. Now, there are other problems in other games where reaching very far in the game could cause these issues. And the reason basically that this happens is that the game developers simply didn't program a win state into the game. They were especially these old arcade games, it was intended that you just keep playing. However, in the case of Pac-Man, the programmers assumed nobody is going to get to level 256. The game is just supposed to go on forever, and because it is so difficult to get there, they didn't test it. So they probably, when they shipped that game, they had no idea that this glitch would exist, just simply because they didn't expect anybody to get to level 256. And this is, a reoccurring thing in video games is that oftentimes you find bugs and things that are hard to test, and in situations that are outside of the norm. And in this case, it's really, really hard to properly test what happens when somebody gets that far in the game. So they just probably assumed that if somebody did get that far, that the game would just continue working, which it does not.
It's a really great example of how finding a glitch can feel like such an accomplishment. You outsmarted the developer.
Yeah,
and in that way, it's more like your skill itself at the game surpassed what the developer thought was even possible.
Yeah, exactly. There indeed there are people who specifically glitch hunt, who are very good at looking for those, the gaps between the cracks, as it were. And oftentimes that's where they start looking. They look in places, what is hard to test? What can we, how can we exploit some of this stuff? And for example, in the case of some of those Ocarina of Time glitches, many of those were found either by looking at the game's source code or very, very closely analyzing the state of the game. Normally with a cheat engine where you're looking at specific values, what Link's state is when he's moving around. And you really need these tools in order to find some of these more obscure glitches.
And it's funny, even having those tools doesn't mean the tools themselves don't figure it out for you. Right. It's you're just because you have a scalpel doesn't mean you know what you're doing when you're doing an autopsy. Right. You got to use what you're given to figure stuff out.
Yeah, exactly. Although One of the most recent glitches that was found in Ocarina of Time, which is the they call it like stale reference manipulation. It basically leads to arbitrary code execution. This is kind of the holy grail glitch for any speedrun, because it basically allows whoever's controlling it to tell the game to literally do whatever. You can tell warp me to the end of the game. You can say, give me 1 billion of this. Some people with a lot of time on their hands have even used arbitrary code execution. Like there was one demo where Super Mario was completely reprogrammed to display Twitch chat. So, those are some things that you can do with arbitrary code execution. And they found it in Ocarina of Time just because some speedrunner noticed some weird behavior. And he was just like, that's kind of weird. And then they investigated it, and it turned out that they could do some really broken stuff with it. So like the current Ocarina of Time any percent speedrun, you basically just muck around in Kokiri Village for about 2 minutes, perform the glitch, and then the game ends. You don't do anything.
It's basically just how quickly can you perform this one glitch?
Exactly.
So it's not even a full game. Obviously any percent, but it's less of an Ocarina speed run as it is that one glitch speed run.
Exactly. Yeah, and for games that are very glitchy, oftentimes their any percent speed runs are just that. For popular ones like Ocarina of Time, that means that instead what they do is that they have a bunch of different categories. So like any percent is one category. There's 100%. There's any percent glitchless. There are actually 2 glitchless categories, but whatever. So because it's popular and because it's so broken, it means that there are lots of categories that have different rules about what's allowed. Simply because it's a beloved game and people want to see the game played. And if it's just that one glitch, people get bored.
Right. You want to see different techniques facing off against each other.
Exactly. Well, it's exciting for some people. For me personally, I like seeing more of the game.
I mean, it might be kind of fun to watch. Like, I haven't seen them at all, but except for the me. It's fun to watch once, and especially if you have someone like I did with you. You were like, yeah, so this is what happened here, and
yep.
Like, oh, okay, that's cool. But I probably wouldn't watch 6 people do it.
Right. Yeah. All right. So the last question you had was the Super Mario Minus World.
Yes.
Okay, so this was one that I was super unfamiliar with, and I'm going to have to do a little bit of speculation since the documentation on exactly why this happens isn't so good. But so this is yet another instance of the game basically trying to load something that isn't supposed to be there. So it's called Minus World because it displays the world just as -1. Now, it's actually not Minus World. Apparently, it's technically, where is it? Yeah, it's technically World 36-1. Because Super Mario Bros. The levels are assembled into stages, so it's like, so it's one. So you've got like World 1-1, 1-2, and then once you beat that world, you go on to World 2, and you have level 2, 1, 2, 2. So this is technically level 36-1. However, the game doesn't properly display 36. It ends up just looking like -1.
Oh.
So the Wikipedia page states that it just shows a blank graphic for 36. Not quite sure why, but probably because the developers assumed that, the last world is World 9, so we don't need to display 2-digit numbers.
They didn't teach it how.
So the exact methodology for how this works is you have to clip through a wall into a warp zone and then go down the pipe. Here's kind of where I have to get into speculation, but I believe what it is, I don't know much about how you clip through the wall. It has to do with collision being weird, where once you're inside of the wall, the game kind of stops knowing what to do. And because you clip through the wall, it seems that the warp zone isn't actually fully loaded. And apparently with this glitch, if you move too far over in the warp zone, it'll actually display welcome to warp zone and the glitch won't work because the room is properly loaded. But if you go through the pipe before before it's properly loaded, you can instead, again, the game will basically access junk data and send you to a junk level. It's going to read a whole bunch of random crap and try to interpret that as a level.
So it's I'm seeing a lot of correlation or a lot of similarity between this and, like, again, the Missingno Glitch or the gate of not the Gate of Time one, but the one we're talking about from Dark Souls. The environment.
Yep, or like the bottle glitch in Ocarina.
Yeah, yeah. Like the environment and the players. Like, separate. So it's like in the Missingno case, it was they accessed the wrong data because you met certain conditions and went to a place when other conditions were supposed to be the case.
Yeah, exactly.
Here with the Mario, right, where we weren't supposed to get into there that way, and as a result, like, if you go too far, just like if you do with the Missingno Glitch, if you take a couple steps too far, then the glitch cancels out and it doesn't happen, right? If you are all the way into,
exactly.
Yeah. So then, I'm starting to get an idea of just like how glitches kind of work, which is cool. That's the point of this episode, right?
Yeah, totally. Like a lot of these ones, especially ones that let you get into like secret levels or secret Pokemon or anything like that, these are all typically you're accessing stuff that wasn't supposed to be accessed. In some cases, you can use this to do things like access levels that were cut. Sometimes games ship with content that is unfinished and isn't accessible normally, but you can actually glitch into. I don't know of any. What's a good example from that? For example, there are some enemies in Dark Souls that are unused that you can actually load up. And I don't know of a glitch to do it, but you can, if you go in there with hacking tools, you can find it. But there are a lot of little things like that that you can exploit. Which is pretty fun.
So I had this one other, or I have several more things I would want to talk about, but one that comes to mind right now.
Yeah, totally.
Last time I was playing Infamous, I think we talked about. I don't think you said you haven't quite played it, but
no, I haven't.
But this glitch feels like something you should. It seems like it could happen in almost any game. There's this part where you're supposed to be protecting this bridge operator while he lowers a bridge so you can go across and fight some other bad guys. While he's working the control panel, because you can hit NPCs in the game that aren't enemies, it will affect your infamy or whatever. I was trying to protect him, but I ended up actually like punching him. But like he did like a Mr. Fantastic, so that the one arm that was operating the controls, like from the elbow to the arm, was still where it was supposed to be, like running the speeds and stuff like that. But then like from the whole bicep was like 8 feet long, and he was like lying where he was supposed to be. So he's like getting up on the yelling at me or whatever, like doing that animation he would do like when he's pissed off at you. But like his arm is all stretched over to where it's supposed to be, and it's like still doing the thing it's supposed to be doing. So it seems almost like the game is trying to do two things at once with that character. Is that a pretty common thing?
Yeah, that is pretty common. So what's happening there is that's the game's animation system breaking. Obviously. So I can only speculate as to exactly why that happened, but very clearly something about that animation meant that his arm was locked in there. It could be that it could be that like his arm is basically locked into the animation somehow, like it basically becomes part of the switch while it's moving. And then because you interrupted it, it meant that it then overlaid the other animation of him getting hit and getting up and being mad while this other thing was still going.
And then the baffling thing to me is that it must have somehow mathematically generated the space between his shoulder and the still functioning arm. Like,
yeah, so that's an interesting one, and let me talk about that. So you're basically right. The way that the reason that it got really long is because of how 3D graphics work. So the character is made up of a whole bunch of vertexes. The vertexes are connected with edges, faces, typically triangle, square possible. So you had one section of his model doing one animation, and then the other section was elsewhere, and that meant that those edges were stretched. So pretty much it would have been like untextured. The texture would have just been like frozen at whatever vertex or whatever faces were stretched out. But yeah, it's just taking the triangles. The triangles are
sorry, my
internet.
Well, I'm sorry, my internet was being wonky. Could you repeat that? Everything from the faces being like having whatever.
Oh yeah, totally.
You're already rendered with. They're just like stuck there.
Yeah. So what's happening there is that that little triangle that's supposed to just be a tiny part of his arm is being stretched out. So those edges are elongated, the faces as well. And what you'll notice is that each one of those, that long triangle, will have just one color. The texture won't like automatically repeat or anything. It'll just be stretched out and look weird.
Mm. Yeah, I guess I wasn't paying too much attention to that, but I think I have a picture of it somewhere. If I do, then I'll try to put it up on like the YouTube video or link it somewhere so people can see it. But I'll try to find it and see what the textures looked like. I mean, obviously it was immediately weird looking.
Mm-hmm.
Like, I think I was just more baffled that the game was doing that, but that's interesting. So basically, one part of him is stuck in one animation, and the rest of him is moved on to a new animation.
Yeah, exactly.
And that small section is just connecting the two.
Mm-hmm. Yeah, in all likelihood, the developers either forgot or because of a weird state, they basically forgot that if somebody is hit while they're doing this, they really need to cancel the animation. But they probably forgot, or a bug prevented it from being canceled, which led to that weird situation.
It's especially interesting in that game where people with superpowers are just sort of popping up all over the place.
Mm-hmm.
It's like you can kind of like build a headcanon that was just that guy's superpower.
Love it.
He's just super stretchy and very good at multitasking.
Yeah. All right. So what else would you like me to talk about?
I think it's interesting the way that glitches have impacted the culture of gaming, like, and how that has changes. Like, we talk a lot about not only breaking games, but how gaming has itself changed over the course of the years. Now we have online games. Now we have games kind of taken more seriously as art. But we also have games where, back in the age of Pokemon Red and Blue, Ocarina of Time, and even I would say a good portion of like the PS3 era, like of gaming, by then it was starting to change. I think that was the first generation of consoles where active patching could be done to existing games. But prior to that, a game was sold to you on a disc or a cartridge, and it was not connected to the internet. So whatever was buggy about it was just on there.
Yeah.
Nowadays, these kinds of glitches that we love talking about and finding, I feel like as quickly as they can be found in modern gaming, they can just be fixed.
Right.
And it's a little bit of a shame.
Yeah. I mean, for all of the interesting glitches that we talk about, there are also a lot of glitches that just like crash the game, that detract from the experience rather than improve it. So it really does mean that it's kind of two sides of the same coin. So while games can be released and have the interesting glitches removed, they can also have the really bad glitches removed. I do think that good developers will understand when a glitch was doing something interesting, though, and some will actually either leave the interesting ones in or even add features in that help replicate it. So like a really one that immediately comes to mind is back in Minecraft, there was this glitch that allowed you to basically power minecarts. If you got two minecarts running right next to each other, they would actually accelerate because they kind of like clipped into each other and the physics wigged out. So when that bug was removed, the developer added in powered minecart rails so that you could basically do the same thing but in a less glitchy way.
That also kind of reminds me of that Breath of the Wild thing where you're not supposed to be able to control, like, use the magnesis on anything you're standing on.
Right.
What if you put a cart on another cart and then magnetize the blower cart?
Yep. You can just fly.
So in that case, is it sort of like the game can't, like, the two carts in Minecraft are clipping, and are both carts being attempted to push in the same direction, and so that push becomes perpetual?
Something like that. I think it has to do with them with the collision resolution, where they're trying to stop colliding with each other, but they end up going in the same direction and stay colliding. So you can gain quite a bit of speed that way.
Yeah, that's crazy.
Yeah.
And I feel like bouncing off that topic again, like, so we've talked about how big glitches are in the speedrun community. And I think there's a lot of games that are very famous just for their speedrunning alone.
Yes.
And those games end up getting remade because of their popularity, but the designers don't realize how important the glitches themselves were to a core part of the fan base. Ocarina of Time is a good example of that. Like, obviously they fixed a lot of the glitches when they translated it to the 3DS.
Yep.
They had to build it. I mean, honestly, it probably would have been difficult to replicate some of those glitches if you're building it on new hardware.
Yeah, it can be. Some glitches only work, in very specific situations. And if you are remaking the game, it might be difficult to preserve some of that. Like we talked about how 8-bit numbers roll over after 256. If you're on new hardware and the smallest number you can get is 16 bits, suddenly that glitch isn't going to happen anymore.
Right.
Or the developer has to like intentionally program the glitch in, which most developers aren't going to do.
At which point it becomes not a glitch.
Exactly.
It's a game mechanic.
Yep.
And I think another famous example is the battle for Bikini Bottom. I think a lot of people were like, yeah, this is okay. Like the new version of it, the rehydrated version of it, it looks good. It plays fine. Like it plays how it's supposed to. But like all the speedrunning glitches stuff that made it really popular. So it's almost like this isn't the superior version almost entirely because of that. Right. And it's sort of an interesting take where it's like, and even if there were glitches, they probably would have patched them.
Right, exactly.
It's such a well-known IP that I don't think we take the gamble of being like, well, that's a fun glitch.
Yeah, especially if you're remaking the game from the ground up. There's no easy way of just preserving the glitches. Like I said, you'd have to program them back in, and at which point it becomes a feature.
Now, there are games where they do try to turn like the concept of glitching into a mechanic. Did you ever play Aeon, is it not Aeon Flux? Axiom Verge? No,
I haven't.
So there's a like little gun in that game. It's called like the glitch gun. You're supposed to be able to find areas that already look a little bit glitchy and then shoot it with the glitch gun, and it like uncovers secret passageways. And it's like, it's an interesting thing because obviously that's not a glitch. Right. It's by its very nature, it's a mechanic, like we were just talking about.
Right.
So like, what does it mean about our culture, the gaming culture, that we're willing to accept, and some people even praised the use of glitches as a mechanic
Mm-hmm.
in the game.
Yeah. So on that subject, I think because we grew up with, these glitches actually happening, people, especially with ones that were interesting, people kind of got attached to them, and it's kind of become part of, part of gaming, part of the gaming space. So, reusing that, especially in a game that's already about virtual worlds and such, it's hard not to include some references to glitches at that point.
Yeah, that's true.
Just because it's so culturally embedded.
Mm-hmm. I feel like it misrepresents glitches, though. Like, not only the fact like that, obviously it's not a glitch, like we were just talking about, but also in that, like, it doesn't feel like a glitch if the developer, not only like, it's not like the gun is super well hidden either. It's, you just sort of come across it as a natural part of the story.
Yeah.
It's like the developer hands you this tool and says, here, go tear the game apart. But you're not really tearing the game apart.
Right.
And so it's almost like a mislead. Like, it kind of cheapens the thrill. Like, it lacks that kind of I'm outsmarting the developer feeling that comes with like clipping through a wall and clipping through the Temple of Time wall.
Yeah.
Like, I was not supposed to be able to do this, but I did. Like, that's a cool thing. Of course, the glitches that I've actually encountered in my life have always been on accident. I've never like accomplished that glitch or any other. But like, anytime I did, I'm like, oh man, I'm outside of the, like, what would you call it? Out of bounds?
Yeah, out of bounds.
Yeah, like when you like, I feel like that's happened to any gamer that's played enough.
Oh
games.
yeah.
You just ended up out of bounds at some point. And you're like, whoa, this is trippy. Look, I can see everything from beneath the floor. There is no floor. Everything's just faces.
Yeah.
Like, you can't. I feel like you can't really accomplish that. Like, I don't know. It's interesting to. You're right. I feel like it's too big of a part to not reference. But I also wonder, because I don't remember that game, Axiom Verge, doing anything particularly notable, like making any real points about glitches by using glitches as a mechanic. It was sort of like, remember glitches? Yeah, we make glitches.
Yeah.
So I don't know. It's interesting. Like, we're kind of, I don't know. To me, it just sort of feels like, and I feel like an old man saying it, but it's like we've said it before. Where it's like, I feel like some of the magic of gaming that we grew up with, at least, is like kind of just disappearing a little bit.
Yeah, and I mean, the good news is, at least on the side of glitches, is that now that indie gaming is so big, they don't have 100-person QA departments like AAA games do in order to hunt down their bugs. Not that AAA games have fewer bugs, they just tend to be more annoying these days. I mean, there's been many high profile incidents of AAA games releasing with, in pretty broken states. But oftentimes it's kind of not interesting bugs. It's just annoying.
Then you also end up with like Cyberpunk 97, which do you know anything about that one?
Yeah, I know a bit about its release and some of the bugs.
You want to go into a couple of those?
So, like, some of the bugs that I know are things like, a lot of it is really either oversights. So things like, oh, I walked into a street and it was like 7 of the same person there. That's probably because they've got some code that tells the game how to create crowds, and it's probably just random. They're probably just taking some, basically rolling some dice and displaying some characters. Now, the problem with using pure randomness is that it's random. And anybody who's played Yahtzee can tell you sometimes if you roll 6 dice, it comes up all 6s. Which may have been what happened there. It's also possible that there was a bug where it got stuck somehow, where it basically was selecting a default or it wasn't properly checking for the next thing, and that ended up with a really weird, really weird set of characters being displayed. 10 clones or whatever.
Mm-hmm.
And then another bug, another famous one is like the flying, flying cars and such.
Mm-hmm.
That one I'm a little less sure of, but I'm pretty sure it comes down to either, probably one thing would be like they're actually following a path. So, if you need a car to drive around, you have to set up a path that it follows. And if somebody forgot to update that after something was changed, you could very easily have a car that just lifts off. I know I've said this a lot, but the computer doesn't know that gravity should apply unless you tell it to. And if you're instead in a mode where it's ignoring gravity and you don't, then it will ignore gravity, basically. And you need to use, the artists or game designers need to make sure that whatever path they sent it on looks like it obeys gravity, because it's just going to follow that path.
It is immensely funny to me how often we've come back to the computer doesn't know. It's like this thing is objectively way smarter than I'll ever be, but it needs to be told stuff.
Yes. I'd say if you have one takeaway is that computers have no common sense, and that includes video games. So things that seem like they should be very easy, like just knowing that objects are solid, computers can't do that. They have to be told how to, and the ways that you do that are going to have they're going to have trade-offs. They're going to have bugs, and because of that, you can get things that seem ridiculous to us happen in the virtual world.
It's it's kind of like having a digital DM, where it's like even if your DM knows almost everything, there's no way they know everything, and you might stump them a couple of times, and they might misremember something that happened before or something like that. But it's still a computer. It's just the file wasn't there, or it was the wrong file, or I'm reading from the wrong place.
Yep.
You told me to, and I didn't know better.
Yep, exactly.
And so I'm looking forward. I hope that whenever we do, if we ever actually manage true artificial intelligence, that there's at least a good couple of years of AI robots developing video games before Armageddon. I would love. I would love to see a world with actual AI that is learning. Okay, that was broken as fuck. How do I not repeat that?
Yeah, well, the good news is that even if somebody does create a real AI, it's unlikely to lead to Armageddon. It also seems very unlikely that we're going to get there anytime soon. Nobody has a good way of knowing that. AI is going to continue to be very useful in limited circumstances, but being able to create a human intelligence it's going to be a while before we get there.
Maybe it'll be some other beings that have to create a human level. This is as far as we could get.
Yeah. Who even knows?
All right,
cool. Do you have any other questions that I can answer?
No, I think that wraps up pretty much all the stuff I was thinking about. Do you have any other topics you want to bring up on the notion of glitches?
I think that's about it.
Okay. All right.
Yep, I can hear you.
Okay. There's a little bit of a lag, but that's okay. I think we could safely call it here for this one.
Yes. Yeah.
Thanks for agreeing to
all right.
And I'm glad that we could finally talk about some glitches in depth, because I honestly am walking away with this with a way better understanding of how all of this stuff works. Being able to correlate all these glitches to each other. Okay, now I'm starting to get it. Makes a lot of sense now.
Yeah, of course.
All right, man. Well then, how about do you want to go ahead and sign it off?
Yeah, well, until next time, hope you learned something new, and be sure to like and subscribe to the podcast on whatever media platform you found us on.
Yes, please do. All right.